Hello friends, here is Mr. Ramesh Chandra and taking a lecture on Introduction to Trigonometry. Now let's talk about the trigonometric ratios. What are the trigonometric ratios and how these works? I know all of you may have seen these pictures of Qutub Minar, as you can see here. You can see this is a boy standing some far away from the base of the Qutub Minar. And if you want to know the height of this Qutub Minar, then trigonometric ratio will help you to find the height of this Qutub Minar. And you can observe this, there is a right angle triangle. There is another case, as you can see, this is a girl and watching the other shore of the temple, and she want to know the distance between these two shores. So how she can calculate this distance between them? And trigonometry ratio will help her to find the distance between these two shores. And you can observe here is also a right angle triangle. So trigonometric ratio is related to right angle triangle. And if we talk about right angle triangle, then there is a Pythagoras theorem which relates the sides of a right angle triangle. Let's say this side length is A and this is B length and this one is C length. Then we have Pythagoras theorem as A square plus B square is equal to C square. As you can see, this area is equal to this much area and this area is equal to this much area. So A square plus B square equal to C square is the Pythagoras theorem. Let's prove it. As we can see, here is a square of length A plus B, and you can see there are four identical triangles and its area of this blank space is C square, as you can see. Now if we move this triangle this way, then you will get this geometry, and if we move this triangle below and this right side, then you will get this geometry. So you can see there's still the vacant area, this one, the vacant area in this case also equal to C square. How it is? You can see this is A, this is also A, so this area is A square, and this length is B, this length is also B, again this is A square, so this area is also B square. So vacant area is equal to C square, as you can see. So hence we have Pythagoras theorem as A square plus B square equal to C square. As you can observe, one more theorem that is very basic, A plus B whole square is equal to A square plus B square plus 2AB. Let's see the proof of this. You can see this is A and this length is B, and again A and B. So this is a square. So area of this whole square is A plus B whole square. And here you can see this length B and this length is A. So area of this rectangle is AB. Again this length is A, this length is B. So again area of this rectangle is also AB. And this is A square and this is B square. So the whole area A plus B square equal to this area plus twice of AB. Let's see animation proving Pythagoras theorem. As you can see, these are four identical right angle triangle. So this is A, hence it's become A square, and this length is B. So this is B square plus A square, and this vacant area is equal to C square. And here we have again another geometry ABC, as you can see. watch it closely. So this was the Pythagoras theorem, and let's have Pythagorean triplets. These are some 6 Pythagorean triplet, as you can see here. 3, 4 and 5 means 3 square plus 4 square is equal to 5 square. So these are the Pythagorean triplet: 5, 12, 13, 7, 24, 25, 8, 15, 17. What Pythagorean triplet are? You can always have 3 square plus 4 square is equal to 5 square. Again, if you think of 5, 12 and 13, then this would be 5 square plus 12 square is equal to 13 square. So here you can see 7 square, 24 square is equal to 25 square. These are the largest side. The square is equal to the sum of square of these two smallest sides of right angle triangle. So this is right angle triangle. Now this is an angle theta. Now with respect to this angle theta, we call this side as perpendicular, and perpendicular is the opposite to this angle, and this is called base of right angle triangle, and this is the hypotenuse of right angle triangle. So base, perpendicular and hypotenuse, these are all dependent on the angle theta. Let's say we have these two triangles. If this is angle theta, then this is perpendicular P, and this is base B, and this is hypotenuse. Similarly, if this is theta, then this is base. If this is theta, then this is base, and this is perpendicular, and this is hypotenuse. So again, we have a right angle triangle, base, perpendicular and hypotenuse, as you can see. Now here we have very important theorem, as you can see here, that this is the arc. I have plotted this arc assuming this point as center. So you can see this length is equal to this much, but you can observe here one thing: the base is less than the hypotenuse. Let's have another arc. If we make an arc assuming this point as center, then you can observe this perpendicular is equal to this much length, and you can observe that perpendicular is less than the hypotenuse. So we have a statement: hypotenuse is the longest side of right angle triangle. Hence we have these two relations. Let's talk about the trigonometric ratios related to right angle triangle. Let's say we have this angle theta. So with respect to this angle theta, we have ratio sine theta is equal to perpendicular upon hypotenuse, and in the reverse of this, cosec theta is equal to hypotenuse upon perpendicular. So these two ratios are reciprocal of each other. So you can write it here as sine theta into cosec theta. Theta is equal to 1 whenever defined. Similarly, we have another ratios: cos theta equal to base upon hypotenuse, and sec theta is equal to hypotenuse upon base. You can also have the same relation: cos theta into sec theta is equal to 1, and again tan theta is perpendicular upon base, and in the reciprocal of that, cot theta is base upon perpendicular. So this also implies tan theta into cot theta is equal to 1. So this is perpendicular upon hypotenuse, base upon hypotenuse, perpendicular upon base. So we have these 6 trigonometric ratio. Sin theta is related as perpendicular upon hypotenuse, and cosec theta is related as hypotenuse upon perpendicular. Similarly, cos theta is related to base upon hypotenuse, and the sec theta is equal to hypotenuse upon base, and tan theta is the ratio perpendicular upon base, and in reverse cot theta is base upon perpendicular. And we can also memorize it by having a saying that Pandit, Badri, Prasad, Har Har Bole. Saying Pandit, Badri, Prasad, Har Har Bole. You can remember these 6 trigonometric ratio. So let's have learning activity, and I am gonna ask some questions that you remember this trigonometric ratio or not. So let's start with sin theta. What is sin theta? Sin theta is equal to perpendicular upon hypotenuse. Then what about cos theta? Yes, this is base upon hypotenuse. Now let's say, what is sec theta? This is reciprocal of cos theta. It is hypotenuse upon base. Again, last one. Let's say tan theta. What it is? Perpendicular upon base. Let's talk about effect and what the effect is. What are you watching here? You are watching a right angle triangle ABC, another right angle triangle AFG, and ADE. So ABC, AFG, ADE are similar triangle. Hence, we can write triangle ABC similar to triangle AFG similar to triangle ADE. So these three are similar triangle. What does this similar triangle means? This means in triangle ABC, BC upon AB is equal to FG upon AF is equal to DE upon AD. As you can see, BC upon AB is equal to FG upon AF is equal to DE upon AD. So this is the rule of similarity. Now if we have this angle theta for these three similar triangles, and hence we can say that this ratio is equal to tan theta. So what are you observing here? You can observe one thing. The value of the trigonometric ratio of an angle do not vary with the length of the side of a triangle if the angle remain the same. As you can see, if theta remain the same, this will not vary with the sides. Tan theta would be same in all these three similar triangles. Let's have some problem solving ability. Here is question number 1. If sin theta equal to 3 by 5, then find value of other trigonometric ratio for angle theta. Sin theta is equal to 3 by 5. then you may be thinking of that this length is equal to 3 and this length is equal to 5. But there may be a problem like this, like sine theta is equal to 3 by 5, then this may be also 3 into 2 upon 5 into 2, that is 6 by 10. Now you will say that this length is 6 and this length is 10. So to reduce such kind of problem, we have another kind of thinking, that we write this side as 3k and this side as 5k, and k is called the proportionality constant. So let's say this side is 3k, this is 5k, then what is this much? So as you can see, we have a Pythagorean triplet of 3, 4 and 5. So this must be 4k as per Pythagorean triplet. Now what we need to find? We need to find the other trigonometric ratios. So we have sine theta as 3 by 5. So sine theta already been given 3 by 5. Hence the cosec theta, which is reciprocal of this, that is 5 by 3. And we have then cos theta as base upon hypotenuse. So this is 4k upon 5k. K will get cancelled out, hence we will get 4 by 5. And sec theta is equal to the reciprocal of cos, that is 5 by 4. Similarly, we have tan theta. Tan theta is perpendicular upon base, that is 3 by 4. And hence cot theta is equal to the reciprocal of tan, that is 4 by 3. So these are the value of other 6 trigonometric ratio. Let's have another problem. If tan theta is equal to m upon n, then find the value of sine theta, where theta is in between 0 and 90 degree. And so this is a acute angle. As you can see, let's say we have this triangle. Answer for this question is sine theta equal to m upon under root m square plus n square. So you can have here, this is theta, and tan theta is m upon n. So we can write mk here, and this is nk. So what must be the hypotenuse? So we know hypotenuse square is equal to base square plus perpendicular square. And what is base? N square k square plus m square k square. So you can take k square as common, it become m square plus n square. So hypotenuse must be under root of k square times m square plus n square. If you take k square outside, then this become k times under root m square plus n square. So what is the hypotenuse? Hypotenuse is k times under root m square plus n square. Now if we have tan theta as m upon n, what we need to find? We need to find sine theta. Hence sine theta is equal to perpendicular upon hypotenuse. So what is perpendicular? mk. mk upon hypotenuse is k times under root m square plus n square. So you will cancel this k, and this is equal to m upon under root m square plus n square. So this is equal to sine theta. Let's have another question, question number 3. In triangle ABC, right angle at B, AC plus AB equal to 9 cm and BC equal to 3 cm, then value of sine C is. Let's have a figure. As you can see, answer to this question is 4 upon 5. So let's solve this question. It is given that AC plus AB equal to 9, means AB plus AC equal to 9 and BC equal to 3 cm. So let's say this is 3 cm and this is x centimeter, x in centimeter. So this must be 9 minus x centimeter. Now as per Pythagoras theorem, 9 minus x whole square is equal to base, that is x square plus 3 square. So we need to apply a minus b square as 9 square is 81 plus x square minus 2 into 9 into x is equal to x square plus 3 square, that is 9. So you can cancel x square by x square, and this is 81 minus 9 is equal to 18x. If you subtract 9 from 81, you will get 72 is equal to 18x. This implies x is equal to 72 upon 18, and this will 4. So you can have x is equal to 4. So if this is equal to 4, then this is also 9 minus 4 is equal to 5. So 3, 4 and 5. Now what we need to find? Sine of C. C is sine of C. So we need to find sine of this angle. So for this angle, sine C is equal to, for this angle 4 become the perpendicular, 4 upon hypotenuse, it is 5. So this is the correct answer. Let's say we have next problem, question number 4. In triangle ABC, BC equal to 7 cm, AC minus AB is equal to 1 cm, and angle B equal to 90 degree. The value of cos A plus cos C is, you to find this value. There are 4 options, as you can see. So answer for this question is C part. Let's have the solution for this question. Now BC is given as 7 cm, and AC minus AB is equal to 1 cm. Angle B is 90 degree. So let's say this length is x. This length is x. So AC must be, as per the given rule, AC minus AB is 1. So AC is equal to AB plus 1. So AB is x. So this is x plus 1. Since ABC is a right angle triangle, so this must follow the Pythagoras theorem. That is x plus 1 whole square is equal to x square plus 7 square. So a plus b square is x square plus 2a into b, that is 1, plus b square, 1 square is 1, is equal to x square plus 7 square. You will get cancel this x square. So this is 2x plus 1 is equal to 49. So 2x is equal to 48. Hence x is equal to 48 divided by 2, and this is 24. So the value of x is equal to 24. Now this is 24, and hence this become equal to 25. Now what we need to have is cos A. For this cos A is equal to base upon hypotenuse, that is 24 upon 25. Now cos C means for this angle cos C, base must be this 7 upon 25. Hence cos A plus cos C is equal to the sum of these two. So cos A plus cos C is equal to 24 by 25 plus 7 by 25, and that is equal to 31 by 25. Hence C is the correct option. Let's move on another question. Question number 5. In the right angle triangle shown, MB plus MA is equal to BC plus AC. If BC is equal to 8 and AC is equal to 10, then value of MB is. Now it is given that BC length is 8. This length is 8. It is given. And AC length is 10. So this is 10 unit. And MB plus MA is equal to BC plus CA. So this length is equal to 80. And we need to find MB. So let's say MB length is equal to X. Hence, since total length this is equal to 18, so we already done this as X. So this length must be 18 minus X. Now since ACM is a right angle triangle, so we can apply Pythagoras theorem as 18 minus X hypotenuse square is equal to base, that is 10 square plus X plus 8 whole square. This is X, this is 8. So this is 18 square plus X square minus 2 into 18 into X is equal to 100 plus X square plus 64 plus 2AB, 2X into 8. So you can cancel this. Then we have 18 square minus 36x is equal to 164 plus 16x. 16x. So this is equal to 18 square is 0, 1, 64, 16, 4, 3. 18 square is 324 minus 164 is equal to 36 plus 16, that is 52x. So here it is 0, 6, 160 is equal to 52x, hence x is equal to 160 upon 52. You can cancel these two by 4 and we have 40 upon 13. So x is equal to 40 upon 13. So what is x? X is MB. Hence MB length is 40 upon 13. Here is exercise 2, that is practice problem. We have 5 problems, question number 1, 2, 3, 4, 5 and their corresponding answer. These are the question for your practice. You solve it your own, and these are based on the theory part that we have studied today and the problem that we solved today. eTuition Live is an online coaching classes run by Mathsarc Education, and this is for JEE Main, Advanced, NDA, KVPY, Olympiad, boards and medical division for NEET and AIMS. You can buy full trigonometric video lectures at mathsarc.com. This is our YouTube channel detail. You can subscribe our YouTube channel.